This is a talk for the EGU General Assembly 2021. The title is Ionospheric Induction of Earthquakes, Fitting the Data. I'm Daniel Helman. Uh, this may be a very controversial subject, but the idea that something in the ionosphere is inducing a current on the crust or in the crust is not so controversial. Uh, in fact, you have geomagnetically induced currents in metal structures uh, quite commonly, mostly in northern and southern high latitudes, um, but still not incredibly controversial. The main features being a large signal in the ionosphere and a conductor in the crust. So, without any further ado, let's begin. Um, so, at the end of the 20th century, a scientist, Sergei Pilinets, um, was able to put together some studies showing that there was a correlation between ionospheric activity and specifically total electron count and large seismic activity, so earthquakes of magnitude 6. This is just a correlation. It's just showing a correlation. It is not showing causation, but still that was quite curious. And in fact, other researchers have done larger statistical analyses and have shown that yes, there is a correlation. However, uh, recently, in 2017, J.N. Thomas did a very good study where he showed that if you take out the um, solar activity and you take out the geomagnetic activity, then this correlation falls apart. Now, um, that has several implications. One being that uh, Dr. Pilinets's first idea that it was perhaps a ground-based process that was causing the anomaly in the ionosphere is probably false, because not only does the statistical significance fall apart, but also if this process were going on and you had large amounts of radon gas, for example, creating a circuit with the ionosphere, you'd need a very large local potential on the order of 100 volts in the ground, and that's not observed. So, so instead, the likely result is that there's some other mechanism going on. And myself, I wrote in an article that was published this last year. The article itself was looking at how seismic electric signals or purported seismic electric signals may work, and actually looking at a new updated method of the Van group, which did not have success. They have lots of false positives, so that's not really working. But I did look at possible generation mechanisms if indeed there is such a thing as precursory seismic electric signals. And one of these mechanisms that seemed reasonable is that there's an ionospheric origin. Now, the fluids within faults, within earthquake faults, are laden with dissolved ions, and so they're much more conductive than the surrounding rock. And in fact, there's something even more significant, which is that there's some data showing that that in the period leading up to an earthquake, in at least one region, there's dissolution of certain types of minerals, and after the earthquake, uh, uh, there's evidence that there had been um, uh, precipitation of different minerals, and this is pretty interesting, um, in that in that if this process is going on, if generally, if and this is localized in Iceland, so one has to be a little bit careful about generalizing. Um, but if this is the process that's going on typically in the period leading up to earthquakes, in other words, if you have um, um, some cause that's leading specifically to dissolution of minerals, which then in turn leads to material failure, uh, and then you have precipitation afterwards. You can have a reasonable explanation for changes in the level and chemistry of groundwater, and that's quite a feat. Um, um, Now, not presently, but previously, um, there was a model called the dilatancy diffusion model of how earthquakes may occur, but this model didn't necessarily pan out because the dimension of the microcracks is really small, so small that that the diffusion of water is not going to work. So, if one is looking for a different mechanism, this seems like likely one. And in fact, you can consider that if there's electromagnetic induction going on with fluids and faults deep down, that 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 may be a mechanism that will allow for extra energy to allow for the dissolution of minerals um, initially. So that's pretty much the mechanism. And in fact, another group has written a comment that was published this year on the article that I published, and that comment shows that using some magnetic data, they're able to see the change in resistivity. And in fact, the change in resistivity is localized to the proper location and depth for the some earthquake that has happened. So um, in a preliminary view, it looks like this may be a reasonable mechanism that fits the data for the phenomena related to ionospheric disturbances and the triggering of large earthquakes. Now, if this is a reasonable model, then obviously it needs checking. It's certainly falsifiable, um, and that's what I intend to do over the next short while. Hopefully, come up with some good uh, some good research there. But I wanted to present this as a preliminary idea, and definitely welcome your questions and comments. Again, this is likely the best fit of the data that are there, that there's a mechanism where the total electron count in the ionosphere um, is raised, for example, through solar activity. And for some of these, then there's induction within the crust, which then leads to dissolution of certain types of minerals, which then leads to failure of rock and large earthquake, and then leads to uh, precipitation of different minerals and changes again to groundwater. Obviously, part of this is dependent on the local rock type, which again may explain some of the variability. And this is just a preliminary hypothesis that needs testing, although it's an interesting one, I would say. Um, Thank you so much for your time, And please feel free to leave a comment here or get in touch with me by email. I'm pretty easy to find on the internet. Thank you so much.